Okay. Hello guys again. I guess we can get started. So for today's webinar, we'll be talking about the impact of topography analysis, what facts to consider for your project to bring the different inputs and outputs that you would be able to obtain from RatedPower. And also, if you guys have any questions throughout this presentation, you're going to have this chat box that you'll be able to enter those questions. And by the end of the webinar, I'll be able to answer those. Okay, so my name is Altair Vega. I'm a principal consultant, passionate for renewables and a sustainable world. And I'm also part of the customer success team here at RatedPower. So in case you are not familiar with, we have this event called Pulse, which is a two-day event happening in Spain, Madrid, that will have professionals from all over places to discuss the transition to a sustainable world, any upcoming challenges, business opportunities, as well as other related topics. So if this is something that you think either yourself or your teammates would like to join, then feel free to mention this to them. And also, there was a discount until yesterday, but we extended it until March 1st. So you can still buy your tickets with the early bird discount until March 1st or while tickets last. Okay. Also, there's some additional resources that we have up here. So this webinar will be more practical, using the tool and seeing the different configurations and outputs. But if you're looking for more in-depth information, including the models, the interpolation that RatedPower uses for the topography, then I strongly recommend watching the webinar that my colleague Felix did last year, which he covers in a very good way the modeling process. We also have the written information about our topography or the topography methodology that you can also access it to. So in the end of the webinar, once you receive that email from us, you will have the link to both of these resources. So we're going to be doing an introduction, talking about the key benefits, software run through, and in the end, we're going to be doing a Q&A. Okay, so because the topic of today's webinar is the impact that topography has in our PV projects, so nothing better than to start with the definition of what is actually a topography. So we can define the topography as being the arrangement of the natural and artificial physical features of an area. And it is also often depicted on a map, showing the elevation and other geographical details. And as an example, we have here the topography map based on the elevation of its surface. Now, some key benefits. So there can be numerous advantages and benefits for applying topography analysis, but in here we can mention some of the main ones applicable to solar plants. And those will be on the installation of the structures, on the construction costs, and also regarding the energy production. Right, so key benefits. So we need to know the topography prior to installation to basically avoid surprises and big changes in the field. Unless, of course, you're willing to install something like this image up here, where we're basically installing everything. So if you would like to also know a little bit about this, you can just search for the solar mountain on either Google or so. But basically, if that's not the case for your project and you have some constraints, some slope limits, then it is also something that we need to take into account. Now, in RatedPower, users are able to run the topography analysis by determining the slope and undulation limits you're willing to install and or apply earthworks if needed. And we also have a slope sensitivity map here based on the topography data, where you will be able to adjust these pins to better and easily identify the most critical areas. Now, regarding the construction costs, so the topography analysis can cause a huge impact in the construction costs. The reason why is because with this analysis, we'll be able to have an idea of how much land it would require to flatten some areas or apply earthwork, and also help mitigate additional work and expenses in the field. So basically, RatedPower will be able to provide you with the volume and cost estimates in case earthworks are necessary. And this is going to provide a huge advantage because companies can now analyze the cost benefit of earthworks in order to maximize the plant capacity, or if it's going to be best to basically discard the structures in the critical zones areas to avoid more expenses. And finally, regarding the energy production. So PV modules can perform differently depending on the tilt azimuth that they are installed, but are also subject to shading losses in the event of installing those types of systems here. So in this case here, we are referring to the terrain and its implications on the road-to-road shading. And if we take a look here at these two examples, we'll see that the energy yield or the energy production is going to be different in both cases. So those, or both cases, they have the same capacity. But in the first one, the top one, we consider the terrain to be completely flat, so zero elevation. Whereas on the second one, we maintain the elevation of this surface. So basically, the idea is that these two models, these two designs will produce or will have different energy production. And if we think for a second, as the sun rises from east to west, if we take a look at these structures here on the lower side, especially in those early hours, those will be shaded, and therefore the overall performance will not be as if they were all on the same level or in a completely flat area. So this 3D energy yield, although it's something that we don't currently have, we are currently working on it, but we do provide you with the 3D PV Colada file that you're able to do this 3D energy analysis elsewhere. Alrighty. So now we're going to be doing a poll question. The question is going to be, how do you prioritize the topographical analysis in the planning stages of a solar project? So A is a primary consideration. B, it's important but secondary to other factors. C, it's considered only if specifically requested. D, it's not a significant factor in our planning process. And E, unsure or not applicable to you. So let's give it a few seconds here so that people can answer. So there's no right or wrong answer here, but it's basically just to have an idea of how do you consider that topography analysis in your current workflow, right? Okay, just a few more seconds. Okay, so I guess we can close the poll. And we can see here that the majority of people in this webinar, or around 74% of the people here that answered, chose A, which means that it's a primary consideration in their current process regarding PV systems. And the second highest one was it's important but secondary to other factors. So you still need to apply that topography analysis, but you have other factors to also consider. So thank you. This is just basically to get an idea of our audience here. And now what we're gonna do is do a software run through. And basically what we're gonna check on RatedPower is gonna be how to upload your topography data. We're gonna check on the topography analysis, and we're also gonna be checking the documentation that you can export, right? So because you don't only want to do all of the studies here, but you also need some data so that you can later on proceed to the next stages of your project. So let me open RatedPower. I'm gonna clone this existing design that we have up here. And then the first thing we're gonna do is check location. So in here, so you guys would be able to upload your topography data. As default, we provide you the topography from Google Earth, but users also have the possibility to upload their own data. It just needs to be either one of these formats that we have up here, either CSV, XYZ, or TXT. So let's say, for example, that you have contour lines or a raster. So if you have any other source of topo data, we also provide you some assistance on it. So you can basically just click this how to link. We'll take you to our knowledge base articles, and we'll be able to guide you step by step on how to convert that to the allowable formats to use in RatedPower. So the next thing we're going to be doing is check the slope sensitivity map that we mentioned a few minutes ago, which basically is going to be based on the topography data that we are using for a particular site. And as we can see here on the right side, we have this line where we have these buttons that we can toggle up or down. And basically what this will allow us is to easily and quickly have an idea of how our area is, how critical those slopes are, and in which particular areas, right? So maybe you want to go all the way up to, you want to see where are the areas up to 25%, right? Either north to south, east to west. So this is something that you would be able to do that here. And also on this, on the left side, there's also some information that we provide you, which is going to be the average elevation here, the maximum, minimum, and as well as the average of the slopes east-west, as well as north to south. Right, so the next thing we're going to be taking how to actually apply topography analysis in RatedPower. So we're going to click up here. And before we actually start to enable any of these buttons up here, let's take a look of what the 3D map looks like for this particular map or for this particular site. Okay. So we can see that it is not entirely flat. It's definitely not flat. And maybe you do have some considerations, some limits that you would like to apply for a similar area, right? What we can do in this case is go back to the 3D map. And if you look here on the left side, we have these three options to apply this slope analysis here. So either north to south, east to west, and you can also do the terrain ondulation. It's pretty easy and straightforward. All we need to do is enable one of these options. And let's say here that we would like to, and this is actually a new feature that we released quite recently, being able to differentiate between the north and the south facing slopes. So let's actually apply some risk restrictions to the north facing slopes or tables, and let's for now install everything facing south, right? So let's uncheck here, and let's say anything from 5 upwards, we don't want to install. So let's do that, and let's do run a design. So we can see here already that RatedPower has shown and labeled those structures that would be facing north, right? So in this case, it's up to 9.1%. And we can also quickly take a look at the 3D map to confirm that those structures have been removed in the areas that we didn't allow, right? So the north facing slopes tables. So the next thing that we can do is also apply some earthwork. In this case, let's set some limits for the south facing and also define earthworks, let's say up to 25%. Let's run the design. And basically what's gonna happen here now is that we're gonna have an additional layer with these earthworks platforms. And if you basically click on any of them, you'll be able to obtain the required fill and cut volume needed for each one of these blocks that need the earthwork, right? So and if you also, again, go back to the 3D map, you will be able to see, for instance, the or the zones that we apply some earthworks, right? Just here an example. And it's going to be the same principle for the east and west option. We do also have the terrain undulation, which the idea here is to limit the variations that we have in our piles. So basically what the user can define here is set the undulation tolerance, let's say up to 100 centimeter. And what the software will do is within a structure, it will compare between the smallest and the highest or the longest pile if that difference is above this 100 centimeter that we have up here. So let me open here this image so that we can better understand. So we have our structure up here. We have the shortest file. We have the longest file. So it's basically gonna compare between these two, take that difference. If it surpasses that limit that we define in RatedPower, then we can either discard completely these structures, or again, we can also apply earthworks in order to maximize our PV plant. All right, so there's one more thing that we can apply here, which is gonna be defining the costs for the earthworks. So let me choose a CAPEX template here. Let me open. So you also have the option to specify the price, right, for either cut or your fill. And let's say that in this particular case, we want to define $3 per cubic meter for cut, and let's say $2 for cubic meter for the fill section. So let's save and close, and let's run the design. Okay. So now let's click here, documents, and let's export some documents to get these topography data. So below quantities, let's get the financial. Let's also get the listing of posts, and we can also get this one as well. So if you remember when we were talking about the construction cost, so The reason why it also has some impact on there is because, again, we cannot just assume that we'll be able to install everything, right? So in case you have some limitations, maybe with regards to the structure manufacturer or so, then you need to define those slopes and also how much it would be to install in those particular areas so that later on you can do that cost benefit analysis and define what's going to be best. So the first thing that we can check here is going to be the on the bill of quantities. You will be able to find the total volume fill cut in case your project requires earthwork. The second thing that we can take a look at is going to be on the financial side. So if you remember, we were able to define some pricing, some values here, and therefore we're also going to see the impact of that additional cost into our project, and we'll be able to make a better judgment after. So the other thing that we can take a look is get document here. So this document that will provide you will also have a combination of different elements. So we're gonna see that slope sensitivity map. We're also gonna see the structures, right, for this particular site, the ones that we have installed, the ones that we applied earthwork. So let me just get rid of some of these ones up here, right? And something also good about it is that you zoom in, you're going to see the exact code for this earthwork platform, so that later on you can also open the listing of cables, which is going to be this document up here. If you check the earthworks, we do enable editing, Control F, let's find that platform, and we'll be able to have all of those details with regards to our structures, the total volume, fill, and cut volume here, so that you can later on proceed to the next stages of your projects. And that's about it. Let's go back here. And I guess we can do right now some questions. So let's see what you guys asked up here. So we have here a question. So someone is asking if we can upload a LiDAR for the topography. So the answer is going to be yes, you can. You just need to make sure that you have the coordinates that RatedPower will need, and those will be X, Y, and Z data. And you also need to ensure that the size of the file does not surpass the 500 megabytes allowed for your topography data. Let's see what we have. So does RatedPower do a ground collision test within a structure? So the answer is going to be no. RatedPower does not do a collision test, but what it does is ensure that the minimum ground clearance that the user will define in the software, that will also be applied when placing the structures, and that is placed on the shortest pile, right? So that's something that you can also use to ensure that your structure will be at the right height. What solutions do you recommend when your data exceeds 500 megabytes? So there are different ways that we can approach this case. So for instance, one of the first ones is actually analyzing if your area, if your available area, if the total data that you want to apply, if it is way over the area or the PV area that you intend to use, or if it is just matching the exact site, right? Because if it's way over your usable area, then we can apply some tools or some filters, and that we simply will have the data for the sections that we're going to install our panels. So that can be one of the options. And of course, there's also other things that we can apply. And if you have more questions about this thing, you can always let us know, and we'll be able to help you with that as well. What is the ratio of cut and fill used in the software? So RatedPower tries to ensure a ratio of 50, 50. So it tries to fill as much as it cuts, right? So that's going to be the approach using earthworks in RatedPower. And see if you guys have any. Let's see here. What interpolation model are you using for topography? This is something that, again, we have in our previous webinar, but just to give some information here. So if you're using the topography data from Google Earth, then we're going to be using a RBF, the radial basis function. If you're using your custom topography, then we're going to be using the TIN, which is the triangular interpolation network. And for more information about this, you can, again, just either look at our methodologies or also watch the previous webinar, which my colleague goes in depth about this subject. And alrighty, so I guess we can stay for here. If you guys have more, wait, let me see here. I think there's a few more questions. So can you repeat how you export the design from RatedPower to AutoCAD? Okay. So basically, once you generate a design here, you can simply click the documents. So we're going to provide you a huge variety of documents, and some of those documents are going to be on a DXF or DWG file. And for that specific one, it's going to be this topography analysis document. Okay. So we'll have another one. When will TV design support rain following trackers? So that's a good question. This is something that we are currently investigating and doing some studies. There's not a short date for when that will be released, but just know that we're currently doing some resources. And if you would like to give or provide any feedback, just let us know so that we can share this with our team. And so there's some trackers that have a new technology, follow the slopes, okay. It's similar to the question that we just answered here. Okay. So if you guys have any other questions, again, feel free to let us know, to send us an email, and we'll be able to answer those as well. So, okay. Alrighty, so thank you guys so much for joining this webinar. You'll also be able to receive an email with a follow-up for this recording, as well as other additional resources. And in case you have any other questions, just let us know and we'll be able to answer you also. Okay, so thank you, and I'll see you guys in the next time.